In this video, we solve problem 8.1.19 from Essentials of Statistics, 6th edition by Mario Triola. The problem statement says that this test statistic of z equals 2.78 is obtained when testing the claim that the population proportion is not equal to 0.118. In part A, we're asked to identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. Then we're asked to find the p-value, and then we're asked whether or not we should reject the null, given that our significance level is alpha equals 0.10. So in order to do this, I'm going to share my paper with you. And we'll just do all of this on the piece of paper. First, we're asked to identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. So I would start by stating the claim, which is that population proportion is not equal to 0.118. Since this does not contain the condition of equality, we will come up with a corresponding statement that does contain the condition of equality. The one with the equal sign is the null. The other one is the alternative hypothesis. So it looks like our claim is the alternative hypothesis this time. And then we just look at that alternative hypothesis, and that's going to decide for us whether this is two-tailed, left-tailed, or right-tailed. If there was a strictly less than sign, so the arrow would point to the left, it would be left-tailed. If there was a strictly greater than sign, the arrow would point to the right, it would be right-tailed. But if you have p is not equal to this, that's a two-tailed test. We don't care if it's the true population proportion is higher than this or lower than this. If it's extremely different from p equals 0.118, either to the left or the right, we're going to reject that null hypothesis. So this is a two-tailed test. And this is a picture of the sampling distribution of sample proportions. Sample proportions represented by p hat. So if we were to come up with a bunch of samples that all had the same size and compute a sample proportion for each of those samples, and then look at the distribution of those sample proportions, this is what this would be. We studied this back in chapter 6 in lesson 6.3. And we know from chapter 6 that p hat is an unbiased estimator of p, which just means that the mean of the sample proportions is equal to the actual proportion. Now, we're going to assume, temporarily, we might decide to reject it later, that the null hypothesis is true. So we're going to assume that the population proportion is actually 0.118, and then ask ourselves, well, is it extremely rare to get a p hat like the one that we got, the p hat that goes with this test statistic, z equals 2.78. Okay, so it's a two-tailed test, and we're going to be looking at area in two tails. We'll have area over here and area over here. Okay, so now we want to find the p-value, and the p-value is the area to, like, the area corresponding to z-scores that are more extreme than the z-score that we have. So this is z equals 2.78. Now that goes with a particular value of p hat from our sample proportion. I don't remember, or actually I don't know what that value is. They never gave it to us, but they told us that p hat corresponds to this z-score. So if these are values of p hat, and I've got all the possible values of p hat down here with the mean equal to that assumed population proportion of 0.118. Down here, I want to look at z-scores. Those have a mean of 0 and a standard deviation of 1. And they're saying that the test statistic is equal to 2.78. So this value of p hat is 2.78, standard deviations above the mean, provided that we're assuming that true population proportion is 0.118. So the question is, well, what is this area? And then since it's a two-tailed test, the p-value is not just that area, it's that area plus that area over there. It's going to be exactly the same area. It's sort of a mirror image on the other side because it's a two-tailed test. So what we need to do is we need to find the area to the right of z equals 2.78, which is the same as the area to the right of p hat, whatever that p hat value is that gave us this z-score. We're going to find that area to the right, and then we're going to double it to get the area in two tails. And that area in the two tails is equal to our p-value. Okay, so for part B, we want the area, we want 2 times the area to the right of z equals 2.78. So we want 2 times the probability that z is greater than 2.78. Now, we don't have areas to the right in our table. We only have areas to the left. So we could, if we want the area to the left, or excuse me, if we want the area to the right, we can find the area to the right by taking 1 and subtracting the area to the left. So that's the probability that z is less than 2.78. So we're going to take all of that, 1 minus that area to the left. It's going to give us the area to the right, and then we're going to double it because we want the area on both sides, the mirror image. Now this we can find in our table, so I will show you my table now. Now p or z equals 2.78, that's right here. That's what I want. So I go down to z equals 2.7, and then I go over 8. So I go 2.70, 2.71, 2.72, 2.73, 2.74, 2.75, 2.76, 2.77, and finally 2.78. So we are right here. Actually, I think I just missed it. Clear. There we go. We do that again. It's in this blue row. 2.78 is right there. So the area to the left of 2.78 is 0.933. It's a little bit, or 973, 9973. Wow, having trouble tonight. So I have 0.9973. And if I subtract that from 1, I get 0. It looks like 2.7 times 10 to the negative 3. So that is 0.0027. And then we're going to take that and multiply by 2. And that's the area in two tails. So it's going to be 5.4 times 10 to the negative 3, which is 0.0054. Oops, excuse me. So this is 0.0027, and this is 0.0027. And when you add them together, you get the p-value. Okay. So that is our answer for part B. So this was a two-tailed test. And we're asked to round to 3 decimal places. I rounded to 4, so I will have to, that 0054, I will have to round to 0.005. Okay, great. And now we're asked to state our conclusion. So again, I'm thinking about that rare event rule. And our alpha level is 0.10. So what we do is we compare this p-value to our alpha level. So we'll say since p, which is 0.0054, is less than alpha, which is 0.10. Since that's true, well, that means getting a test statistic that is that high, or alternatively, getting a value of p hat that is that high is very rare, or that extreme is very rare. What's the probability of getting a p hat value that is that extreme or more extreme than that in either direction? That probability is about 0.005. well, that probability is exactly equal to 0.0054, or if you prefer to think of it this way, 0.5%. And we're comparing that to 10%. So the chance of getting a sample proportion that was that high is very small, given that our true population proportion is 0.0018. So maybe if that's the case, if we have this very rare event happening, maybe our initial assumption was incorrect. So the initial assumption is that the population proportion is equal to 0.118. That's our null hypothesis. Since it's so rare to get this value, when we have this population proportion, we're going to say maybe the population proportion that we started with was wrong. Maybe that isn't the population proportion. So we're going to reject the null. So I'm thinking through the rare event rule, but you don't have to. There's a mnemonic device for this. We've got a mnemonic that says if P is low, the null must go. So P is smaller than alpha, we reject the null. If P is greater than alpha, we fail to reject the null. The mnemonic is if P is low, the null must go. If P is high, the null can fly. You can use that if you prefer. But I prefer to think through that rare event rule because I think it makes more sense. Okay, so we've got this. And now the question is, well, what do we say about that initial claim? So the claim was that the true population proportion is not equal to 0.118. And we rejected the idea that it was equal to 0.118. So what does that tell us? Well, if we're saying that this is not true, we're saying, well, that seems to be true. It's either this or it's this. So in our case, for this example, rejecting the null means that we have sufficient evidence to support the claim. Let's say we have sufficient evidence to support the claim that the true population proportion is not equal to 0.118.